Welcome to In 5 Minutes. Now we'll write a program to sort 5 numbers in the array in ascending order. Basically it's a sorting a list problem. Now how the overall program will be: first we'll define array of size 5, then we'll input 5 numbers in the array using usual for loop, then we'll rearrange the numbers in the array in ascending order, that is smallest to largest value, and then we'll output the rearranged, that is sorted array. Now for sorting array, that is sorting list of numbers or list of values in any ascending or descending order, there are so many methods available in computer science. One of these methods I'll be using over here is called as bubble sort method. Consider the array A of size 5 with some values. Let's see how this bubble sort method works to sort the array. Here the method is described like this. It compares two consecutive elements, 0th and first and second, second and third and fourth, at a time in pair. If in the pair next number is smaller, then it interchanges the two values. In that process, it brings smaller value up and bigger value down the array. Now for that, first we decide what is the last index of the array to be processed. In this case, since array size is 5, the last index to be processed will be index 4. Let's take example L value, L variable that indicates the last index as 4. Then we have to move through the array from 0 to 4 and compare 0th and first and second, third and fourth. Now to move through the array, we'll utilize some variable I going from 0 to L, that is 0 to 4, and compare every time ith and I plus 1 number. If I plus 1 number is smaller than ith number, we'll interchange the values. Now how it exactly works, to understand that, we'll draw this array again and again repeatedly and see what is happening inside the array as we start sorting the array. So first time we'll move from 0 to L, that is 0 to 4. Now when we move from 0 to 4 in the array, in that process what we'll get will not be a sorted array, but we'll get the largest number at the bottom, that is we'll get the value 8 at the 4th index in this array. Now leaving 8 value, that is 4th value aside, we'll go to the rest of the array and apply same procedure again, that is we'll move from 0 to 3 and apply same procedure, that is comparing two consecutive numbers. If next is smaller, interchange. In that process we'll get second largest number at the third location. Again we'll go from 0 to 2 and apply same procedure till we reach 0 to 1. So to begin with, first we decided what is the last index of our array to be processed. Then using some I variable, we'll move from 0 to L and compare ith and I plus 1 number. So here we'll compare 0th and first number. Since A1 is smaller, interchange A1 and A0. So move 4 up, 6 down. Then compare A1 and A2. This time A1 is 6 and A2 is 8. So since A2 is already bigger, no change, 8 remains as it is. Compare A2, A3, it is 3 and 8 will compare. Since A3 is smaller than A2, interchange the values. So 3 moves up and 8 down. Again compare A3, A4. This time it is 8 and 5. Since A4 is smaller, interchange the values. So 5 moves up and 8 down. In that process we got the largest number at the bottom of the array. Now leaving this number as it is, we'll move from 0 to 3, that is from 0 to 3 using again some index variable I, and compare consecutive numbers and apply same principle again. So let's see what happens. Compare 0 and 1, no change. Compare 1 and 2, yeah, there's a change. 3 moves up and 6 down. Again compare second and third. Again third is smaller, interchange. 5 moves up and 6 down. 8 as it is will not handle. So now this time the array is sorted up to second last index, that is third and fourth element is sorted. Again for this array we'll apply same principle from 0 to 2. Let's see what happens. Compare 0th and first in this array. So it is first number is smaller, so interchange 3 and 4. Again compare first and second, no change because second is already bigger. 6 and 8 will not handle. We got array sorted up to 2, that is index 2, 3, 4 are sorted by our logic. Now we can see the entire array is sorted actually, but we are not supposed to stop over here because program doesn't know and computer doesn't know whether the array is sorted. We can see it. Say L equal to 1 again and move through the array from 0 to 1. Now in this step the array will get fully sorted because we will be comparing only 0th and first number. In that case 3 as it is, 4 as it is, and 5, 6 and 8 remain as it is, and the entire array get sorted. Now this is the last array that you have to display as a resultant array. Now let's see the entire logic in the program.